Hey YouTubers, Steven here. Okay, today, Project Green Marine. We're going to be doing the important stuff. First we need a little thin steel bar. Then, need some wider flat steel bar. And then, picture of a propeller. Now, what I'm doing, the idea, okay, I'm going with the shape and style of the Minn Kota propeller, you know, like on the electric trolling motors, because I was looking at the trolling motors that, or the propellers rather, that the human power boats usually use, and they're very similar to an airplane propeller, but they're designed for low RPM, and they're very long, they're very thin, and most of them are set in a way so that it's actually pulling the water instead of pushing the water. I wrote to Minn Kota. I asked them, you know, about the specifications. You know, what kind of speed would I be looking at in a 12-foot boat, you know, with one of their lower end models. What kind of RPM I'd look at, and at 1600 RPM, one propeller will push a 12-foot boat approximately 12 kilometers an hour. To my American friends, I'm sorry, I don't know what the conversion is off the top of my head. It's 1.6 kilometers in a mile, so you can do the math. So it's a beautiful day here in Cole Harbour, Nova Scotia. It's 10:30 in the morning. It's already 27 degrees Celsius with the humidex, which is low 80s, but this is what I love for the winter. Put this paper away. So, my idea is that the bottom of the boat, I'm going to use a bike bracket. Alright, this is where your pedals normally go. You pedal your bicycle. One end's going to have a sprocket. I don't know how well you can see that, so we'll bring it up a little closer. Looks a little rusty because it's been sitting in the shed all winter, and I'm going to clean that up. But I'm going to have 6.5 inches clearance from below the boat, from my propeller blade, wherever this may happen to be, you know. And I'm going to make the blades about 4 inches long. So the idea is I'm going to take the thin steel bar and I'm going to come down 9 inches. That gives me an inch in the center to drill out a 3/8 hole, so that it will slide onto this end of the bottom bracket. And it'll give me a little bit of clearance to get outside here. Just a little bit. And then I'm going to cut this at 9 inches, center it, drill a hole through it. Then I'm going to put it in a vise. I'm going to heat it up with a propane torch. Now, I don't have acetylene. Acetylene would be ideal, but the other part of this project is, you know, for anybody can do it with ordinary tools for free. So I'm going to heat this up, and I'm going to twist the flat plate, or steel plate, steel bar, flat bar, whatever we want to call it. I'm going to twist this to match the twist on the Minn Kota propeller. Now, I went into a Canadian Tire store and I had a protractor and a notepad, and people were looking at me funny, but the pitch on the Minn Kota propeller is 25 degrees in the center, and then it rotates out to about 10 degrees on the end. Now, my measurements may be off a little bit because I am just using a little protractor. And then once this is designed, then what I'm going to do is, with the piece of paper I showed you, I'm going to cut out one blade, and I'm going to lay it on my sheet metal, or my steel plate, and I'm going to trace it out. I'm going to cut it out, and then the idea will be, well, you know, for each blade, is I'm going to weld it on the smaller steel bar. Now, this small bar will be a lot easier to twist and bend to the shape that I want than taking this big piece as it is. Plus, I can get more blades out of this one piece than if I was to make an entire blade 9 inches long. I could probably get 2 out of this, but if I screw up, then I have to go buy a whole new piece. At least if I'm making individual blades, if I screw one up, no problem. I got lots there to make another blade. Alright. Inches. Make sure my line is square, just to be perfect. No sense putting it in the vise. Set it on the vise. Can you see me? Could use a hacksaw, but this is easier. And every man loves an excuse to use a power tool. Alrighty, so I just took this to the bench grinder and just cleaned up the edges a little bit. They're both exactly the same length. Perfect. So next, I need to find center. So what I'm going to do, since I cut these at 9 inches, and they're exactly 9 inches, I'm going to take my measuring tape, and it might be actually easier if I hang it over the edge. I'm going to come down 4 inches on one end, flip the bar around, measure it in there, get it straight, and make another 4-inch mark, which will give me 1 inch in the center, which is exactly what I want. So I'll just draw my straight lines so that they're square. Now I just got to measure again so I have dead center, which of course would be 4.5 inches. And then I just got to find the center in the width. So that's 1 inch. I need a 1/2 inch in between. So I'm going to hold that right at an even inch mark. It's a little unorthodox, I know. And my 1/2 inch mark is right there, so X marks my spot. Like so. Can't see the lens because it's too bright, so hopefully I have that just in the right spot. I'm just going to repeat the process for this piece. Then we're going to drill out our holes. We're going to set up my vise, and then I'm going to heat up the metal, and we're going to give her a twist to 25 degrees. I should actually be able to just line these two up and make my marks so that they're both identical. Or I could put one plate on top of the other and drill through both pieces, and then they're exactly the same, but I'd rather do it one at a time. That way it's perfect. Or if I screw up on one, then they're not both screwed up. And I suppose you could say, well, gee, if you know where center is, why are you doing both the lines? Well, the lines on either side will tell me when I put this in the vise that I'm in the right spot to do the twist so that I can be as accurate as I can. I'm not a machinist. I'm sure a machinist would have all kinds of tricks up their sleeve, but I don't, and I also don't have the great equipment that a machinist has. So line that up right on the inch. There's my half. And even eyeballing it, looks perfect. Alright, get this stuff out of the way. I have a center punch. Can't find it anywhere, so I'm just going to use this awl. It's in the center. To make it easier for when we go to drill the hole, we'll drill a smaller one, and then we'll drill a bigger one. Just because it's easier on the bigger bits if you drill a small hole first and get it started. Oh, right, perfect. Alright. Now, 3/8 needs to be a little bigger than 3/8, and I think that's the biggest bit I got. Now I know I'm probably going to get a lot of comments that I shouldn't do that to the drill bit, but poor man solution when you don't have a bigger bit, and that's perfect. That's exactly what I wanted.